Hello, everyone. Welcome to episode 1 of the SDET Interview Masterclass, powered by Lambda Test. If you're getting ready for your first SDET interview, or you're just stepping into the automation world, this is your launchpad. Today, I'm covering the core beginner level interview questions that almost every recruiter asks in 2025, along with pro level insights to make your answers shine. And here's the twist. We are going beyond textbook answers into real world insights, automation practices, and even how AI is reshaping the SDET role in 2025. As most of you already know, I'm Siddhant Wadhwani, your guide, come mentor through this episode to prep you with the interview questions and respond with the perfect answers. Stay tuned till the end because I'll share a few knowledge bombs that can help you stand out even against more experienced candidates and skip months of trial and error. All right, so let's dive into some of the most common questions that interviewers ask. Starting with the first question, what is the role of an SDET in today's AI-augmented development teams? While we know an SDET, software development engineer in test, is someone that helps bridge the gap between development and testing. Unlike a traditional QA, we don't just find bugs. We also write test automation code, design testing frameworks, and collaborate on building high quality software from day one. In agile teams, the SDET participates in design discussions, builds test automation pipelines, ensures every feature is backed by automated regression checks. The role of an SDET in 2025 has expanded far beyond just writing automated test scripts. We are integrated contributors in development teams responsible for quality advocacy, which means influencing design decisions and discussions early on so that testing isn't an afterthought. Part 2, AI-aided testing, using generative AI to generate, review, and optimize tests. Agentic AI automation, deploying AI agents that autonomously monitor, execute, and even adapt tests during runtime. DevTestOps integration, making sure our tests seamlessly plug into CI/CD pipelines for faster releases. And last but not the least, data-driven insights to track defect patterns and using analytics to guide engineering principles and priorities. For example, in my last project, we leveraged generative AI within our pull request workflow. Whenever a developer made a change, the AI would suggest test cases and our automation framework would instantly validate those changes in staging. This cut the regression cycles from 3 days to just under 3 hours. We made further advancements to leverage AI for several other use cases in testing and automation to generate test plans, test estimates, test cases manually, and write automated scripts. Review automated scripts, suggest potential issues at a product level, recommend fixes and remediations, and also make sure to follow guidelines and best practices that we have defined. Think about modularity, scalability, and several other factors. So I have a pro tip for all of you. In 2025, an SDET isn't just a tester. We are engineers, creators, AI collaborators, and quality enablers, making sure every release is fast, safe, and reliable. Okay, moving to question 2. How is an SDET different from a traditional QA engineer in 2025? The simplest way to put it, QA engineer primarily focuses on manual testing, executing test cases, doing exploratory testing, and logging bugs. On the other hand, we have an SDET who codes automated scripts, builds test frameworks, integrates with CI/CD, and owns DevOps to ensure scalability of tests. So, pro tip here, many companies now merge these roles, but in interviews, they clearly state you bring both coding skill and testing mindset. The overlap is in the testing mindset. Both roles care deeply about quality, but an SDET needs strong programming fundamentals. For example, in Selenium automation, a QA might execute steps manually, but an SDET would create a page object model, parameterize the test data for reusability, and set up a Jenkins or a GitHub action to run these tests automatically in parallel. So think of the AI angle here. The SDET role is evolving. We are now using natural language to test tools, where you can literally describe a test scenario in plain English, and AI generates those test scripts. But the SDET still needs to validate and optimize that code. So the skill set is still technical. Question number 3. What core skills and tools should a modern day SDET master to stay relevant? Well, here's my list for 2025. Programming skills: Java, Python, JavaScript, or TypeScript, but make sure with OOPS concepts. And a bonus here would be knowledge of AI scripting tools like GitHub Copilot, Cursor, or similar. Automation framework knowledge: you have tons of them like Selenium, Robot Framework, Playwright, Cypress, and Appium, to name a few. CI/CD monitoring and observability: you have Jenkins, GitHub Actions, GitLab CI, and several others which we'll talk about shortly. API and DB testing: Postman, REST Assured, Robot Framework, or Playwright APIs. And you already know the several DBs out there. Cloud infrastructure basics: AWS, GCP, OCI, or Azure for test environments. Don't forget non-functional testing. You have JMeter and Locust for performance, Lighthouse, GTmetrix for front of site, and OWASP SAP and Burp Suite for security. We also have AI-assisted testing that we should focus on as tools that adapt locators and generate scripts automatically. So personal tip over here: don't just learn one framework. I started with Selenium, explored several others along the way, and finally moved to Robot Framework for speed, ease of use, and API plus UI integration. And now I experiment with AI tools to see where the industry is heading. Over and above these, knowledge of monitoring and observability tools like Datadog, New Relic, ELK Stack, Grafana, Prometheus with Ansible and Terraform would definitely serve as an advantage. Question 4. How do you decide what to automate and what not to automate? This is a smart one. Well, I use risk-based prioritization. Test critical business flows first, whether it's login page, payments, pricing, or checkout flows. Focus on features with recently modified code areas, test areas, or modules that historically have the most defects. And when we talk about automation, you make sure that you're splitting those tests into smoke tests, which are fast, high priority, and checks that run on every commit, or regression tests, which are broader coverage and run on a nightly or pre-release basis. So again, the pro tip here is, in my last project, we used test impact analysis in our CI pipeline. So only tests affected by recent code changes were run. This reduced the build time from 45 minutes to under 10. Moreover, automate high priority smoke tests so they run on every commit. This prevents major regressions or bugs from reaching production. Question 5. Can you share a real world example of catching a critical defect before release? Yes. During a sprint, while automating the checkout process for an e-commerce application, I discovered that applying a discount code after switching currencies would result in the wrong conversion rate and overcharge customers. This was a high risk, revenue impacting bug that only occurred in a very specific sequence. Although my automation scripts running in a nightly build caught it. And because we had real-time Microsoft Teams alerts from our Jenkins CI, the devs were able to fix it before it reached production. This not only saved potential customer backlash, but also reinforced the business case for investing in early automation. Question 6. How does generative AI change the way SDETs work today? Nowadays, AI is no longer just an experimental add-on. It's become a part of daily SDET workflow. I've used AI in multiple ways, which I'll talk about shortly, but let's give a few examples here. So talking about locator stability, AI-powered locator healing. So if the UI changes, AI finds the closest matching element automatically. Several tools like Testim, Mabel, or Playwright AI plugins do this really well. We built our own in-house robot framework listener that does this. If we talk about script generation, you can describe a test in plain English, and ask AI to generate the boilerplate, whether it's in Selenium, Robot Framework, or Playwright code. This speeds up script writing by 60 to 70%. It also suggests missing edge cases and maintenance of outdated test cases. We also have test data generation, where AI can create edge case data instantly, like names with emojis, random Unicode strings, or massive data sets to stress the app. So the pro tip here is don't let AI be a black box. Always review generated code for efficiency, security, and maintainability. In one case, AI gave me a 40-line playwright test that I myself refactored into 15 lines by using page object model patterns. So in short, AI doesn't replace the SDET, it amplifies us. AI is a co-pilot, not the pilot. It accelerates your work, but human judgment still decides what's valid, ethical, and aligned with business goals. In the future, however, we'll see more agentic AI that runs tests, interprets failures, applies the fixes, and revalidates without human touch. But right now, we are in a hybrid era where AI plus human collaboration delivers the best results. And the final question, how do you collaborate effectively with developers, DevOps, and product teams? And SDET's success isn't just about writing great test code. It's about how well you work in a delivery ecosystem. So here's my approach to cross-team collaboration. With developers, I participate in sprint planning and story grooming, so I can clarify testability upfront. I review pull requests, not just for my own automation code, but also for the application code changes that would impact testing. I push for shift left testing, writing API and unit tests before the UI is ready. When it comes to DevOps, I ensure test automation integrates with CI/CD pipelines. Example, Jenkins, GitHub Actions, Azure DevOps, or likewise. I collaborate on environment setup, containerization with Docker, and ephemeral test environments in Kubernetes. I help define automated quality gates like no merge unless smoke tests pass. And when lastly it comes with product owners or managers, I translate acceptance criteria into test cases and make sure automation covers business critical flows. I give fast feedback on feature readiness, not just past fail, but risk based insights. For example, feature passes functional tests, but load testing shows degradation at 5,000 concurrent users. So, my pro tip here is I maintain a shared quality dashboard which is accessible to all, whether it's developers, QA, product, or leadership. This makes quality transparent and prevents finger pointing. Ultimately, collaboration is about speaking each team's language, that is, technical depth with developers, infrastructure focus with DevOps, and business impact with product. That's how quality becomes a team sport. So let's quickly recap what we covered today. We explored the role of an SDET and how it's evolved in 2025. We learned how to differentiate SDETs from QA engineers, the key skills that make you stand out, and how to prioritize test cases for maximum impact. We also looked at how to spot critical bugs early, and also how and why AI tools are changing the SDET game. And finally, we discussed how to collaborate effectively with developers, DevOps, and product teams. So you're not just an automation engineer, but a true quality partner in the delivery pipeline. All right. Thank you so much, folks, for joining in. In the next episodes, we'll dig into automation frameworks, API testing, best practices, flaky test mitigation, CI/CD integration, and leveraging generative and agentic AI with plenty of pro tips and real-world examples. So if you found this video useful, hit the like, subscribe, and drop your questions or your own interview experiences in the comments below. And remember, great testing isn't just about finding bugs. It's about building confidence in the product before it reaches the customer. So see you in the next one.